In this video, I'd like to walk through the problem that we did in the previous video. But this time, I want to think about the steps that we took and see if there's some sort of picture that we can attach to those steps when we're taking this expression and converting to a harmonic form involving the cosine. Right? So what did we do? For the amplitude in this harmonic form, we went with the square root of the coefficient on cosine squared plus the coefficient on the sine squared, and we ended up with an amplitude of 2. We then factored 2 out of this expression, right, which seemed to get us nowhere until we realized that if we remember our difference angle for the cosine, right, we can actually change this expression into the right side of this formula and use it going in this direction over the equality to end up with a cosine of x minus some angle, right? So at this point we asked, is there some alpha, or what is the alpha, that satisfies cosine alpha equal to negative root 3 over 2 and sine of alpha equal to 1/2. And using our knowledge of special angles, we were able to deduce that we can use 5 pi over 6 for our alpha. So what sort of picture can we attach to this? Let's go to the coordinate plane, and let's take our coefficient on cosine as an x-coordinate. So that's negative root 3. Take the coefficient on sine as a y-coordinate. And so we have the point negative root 3, 1. Notice that if I put a right triangle in here, that the hypotenuse is exactly the r. The hypotenuse, using the Pythagorean theorem, is going to be this expression, which simplifies, of course, to 2. And so here is the angle alpha that I want, and cosine of alpha has to be the x-coordinate over the hypotenuse. Sine of alpha has to be the y-coordinate over the hypotenuse. So this is the picture that we are going to use to help us work through these problems where we want to convert some expression involving cosine x and sine x into the harmonic form. Let's look at an earlier problem that we did. We started this series by thinking about cosine x plus sine x, and we realized that this was the square root of 2 cosine of x minus pi over 4. Right? So let's ignore the fact that we know what this is going to be and focus on this expression here. Right? So the picture here, the coefficient on the cosine is 1, coefficient on the sine is 1, so the ordered pair is just 1, 1. So if I look at this triangle here, this is the alpha that I want. The length of the hypotenuse using the Pythagorean theorem is root 2. So we need an alpha satisfying 1 over negative root 2 for the cosine, and the sine of alpha 1 over root 2 as well, right? So the cosine of alpha has to be 1 over root 2, sine of alpha has to be 1 over root 2. And again, this is a nice special angle for us. We know that alpha has to be pi over 4. So in the next couple of videos, we're going to work through some of these problems without doing any factoring and just focusing on the picture and trying to figure out what this angle is. Hopefully the angles will be special angles that we know, but sometimes we might run into some angles that we don't know. And the question is, what do we do in that case? We'll leave that for a future video.